So once again, I'm here. Audible. Thank you. थैंक यू. इससे पहले फिर से नॉट ऑडिबल हो जाए, लेट्स स्टार्ट टुडेज वर्क. देयर इज अ बेनिफिट, मेरिट एंड डीमेरिट ऑफ टेक्नोलॉजी. Okay, yes, we should start now. So I was talking about that yesterday we discussed about classification of numbers. We talked about various things. हमने real number के बारे में बात की. I would like to mix the language because I was able to read many comments in which students were willing to have mixed language or Hindi or English mix, right? So I would like to have it mixed. तो कल हमने काफी सारे numbers के बारे में बात की. We talked about classification of numbers, real numbers, imaginary numbers also we talked about. And among real numbers we talked about rational, irrational, recurring decimal numbers. Then we talked about integers, and among integers we classified numbers as odd, even, and then we moved to prime and composite numbers, right? Okay. हाँ, प्रशांत बोल रहे हैं आधा घंटा तो ग्लिच ठीक करने में निकल गया, आधा घंटा और ना लगाएं उसके बारे में डिस्कस करने के लिए. लेट्स गेट गोइंग नाउ. सो टुडे वी आर गोइंग टू डिस्कस अबाउट फैक्टर्स. एंड एज आई वाज सेइंग, I have doubt from assignment question. Naman, it's very nice. We should have doubts, and I will keep last 10 minutes for doubts. Okay, I will try to finish my teaching part till the first in the first half or more than that. Last 10-15 minutes I will keep for doubts. So whatever doubts you may have, you can ask me, but keep them for last. Okay, last 10-15 minutes I will spare for that. Okay, so don't worry, your time will not be wasted. We can extend the session by some time. Don't worry. Yes, I will be using both languages. Preeti, don't worry, I'm speaking in English only. But in between I will be using bit Hindi also. Yashwardhan is saying you had given a question yesterday, please solve that. I saw that question being solved in comments. But anyway, if you have any doubts, so I have said this earlier also, I'm saying it again. Whatever doubts you are having from last session or any question, anything you wish to ask, you can keep that for last 15 minutes. I will give you time. Okay, let's proceed now. Factors is our topic, and as I was saying, I could see that you have solved some of the questions based on this topic factors in today's practice session in the daytime also. Maybe some of you were not able to attend, and we have also provided a conceptual video on this topic factors in your non-engineering video section, conceptual video section. You may have seen that also, but we'll briefly cover it here again so as to revise all the things and the concepts involved. Now tell me one thing that yes, you did that. Tell me one thing in the comments. Don't put unnecessary comments. As I said, don't discuss other things. Those who are having any difficulty, you can refresh. Now tell me one thing. Would you like to understand the concepts, increase your understanding, or you wish to just know the shortcuts? What's your take? You wish to develop concepts, you wish to develop understanding, or you wish to just go for the shortcuts? You tell me in the comments. You want shortcuts, formula, or you want conceptual understanding? Archie says both, and Kirti says concepts, Srinivas says concepts, understanding. Swagat says both concepts. To be honest, both. Aditya, good. You should be honest. Very nice. Okay. So I have seen about 10-20 comments. So many of you are saying concepts, and many of you are saying both also. Yes, that's a nice comment. Grima says first concepts, then shortcut. Of course. See, that was the whole idea. If we have conceptual clarity about any topic, then shortcuts are its byproduct. Let me repeat my statement. If you have developed a good understanding of any topic, then its shortcuts or formula or short method, they are just byproduct because you know what you are doing and how what are the limitations, right? But without understanding the concept, if you just remember a particular formula, believe me, it is never going to help you. It is never going to help you, right? And I said in yesterday's session also, and if you have seen the conceptual videos, there also I have said it repeatedly that I don't like to remember formulas. I don't like to teach any shortcuts because there are none. If you do not have the proper understanding, then you cannot apply any formula. And if you have proper understanding, then you are going to directly jump to that only, right? So of course, so both is the part. So first concept, and after understanding the concept, we can directly apply it in a shortcut. Okay, let's move further. So factors is our topic. So factors होते क्या हैं? What are factors? So factors means a number which divide a given number completely, right? So for example, if I'm having a number, say 60, first thing before proceeding further, when I say factors, we talked about this yesterday also. So factors by default, we are talking about positive integral factors, positive integers which divide a given number, right? Is this color visible? Red is okay? Or I can use yellow here. The positive integers which divide a given number, okay? But if question asks about integers only, in that case we need to include the negative ones also, right? Okay, so 60, what is the smallest natural number which divide this number 60? Write in comments. Yes, I'm using yellow. Yes, yellow is better. I can see that. So I would be using yellow. So 60 is a number. Tell me which is the smallest number, smallest factor of 60. Write in the comments. I'm waiting for your comment. Yes, it's 1, of course. And we talked about yesterday that 1 divides every number. 1 is a factor of every number, right? So 1 is the smallest factor. What is the next factor after 1? It is 2, right? 1 divides this number 60, 2 divides this number, 3 also divides, 4 also divides 60 completely, 5 also divides this completely, 6 also divides this completely, right? What is the next number? 7 does not divide. Aryan, I said that -6 will be an integer which divides this number, but when we are talking about factors, so by default we are talking about positive integral factors only, right? So that's why I'm writing only positive integers which divide the given number. So after 1, 2, 3, 4, 5, 6, 7 doesn't divide, 8 doesn't divide, 9 doesn't divide this number, but 10 divides. That's correct. So 10 divides this number, right? After 10, 11 doesn't divide, but 12 divides, right? 12 5s are 60. See, 12 5s are 60. We can see the connection here also. 12 into 5 will be 60. Same way here it was 10 into 6, that was 60. Exactly same way, 4 times 15 will be 60, and 3 times 20 will be 60, and same way 2 times 30 will be 60, and 1 times 60 will be 60, right? Yes, we are playing with it. So all the factors for every number, appear in pairs in such a way that smallest factor and the largest factor, when they are multiplied, they give the number. Second smallest factor, second largest factor, when they are multiplied, they give the number, and so on, right? So what can we conclude from here? So these negative numbers are also factors. They are negative integers which divide. So whenever it will ask about negative integers, so we will include negative also. But right now we are talking about positive ones only. So don't get confused. Right now we are focusing on only positive factors. What can we conclude from here? I'm seeing a lot of spam comments are here. Yes, factor appears in pairs. That's perfectly all right, Harshit and many others. Even number of factors. Okay, Satyam says even number of factors. Rishikesh again says factors appear in pairs. 60 has 12 factors. Wonderful. Factors always appear in pairs. In this case, 6 pairs of factors. Wonderful. See, so we can always see this thing, this pattern, this properties of factors, that factors always appear in pairs, right? Okay, I'm giving you a large number. Let's say 6,000 I'm writing. 6,000. Okay? Can you tell me what will be it's a, say, fourth, yeah, let me take seventh largest factor. Tell me what will be the 7th largest factor of this number 6,000. Can you think of? Try to think. What will be the 7th largest factor of 6,000? I'm not taking names of all the students who are posting the comments, so no need to post the same comment again and again. I am seeing one comment being posted repeatedly. Please don't do that. So right now question is 7th largest factor. Some of you are saying 600, one is 1000. Tanya बोल रही है समझ नहीं आया. Maybe you are focusing on the comments. See, in the comments only focus on your own comment. Don't read comments by others. That can be a distraction. Be focused here. So we have discussed so far that factors of a number always appear in pairs like this. 1 was paired with 60. 1 was the smallest factor which divides 60, and 60 is the largest one. And now what is the probability that 1 multiplied by 60 is 60? Same way 2 was the second smallest factor of 60, and 30 was the second largest factor of 60. So that 2 times 30 is again 60. Same way 3 times 20 is 60, 4 times 15 is 60, and so on. Right? So same way for every number we have discussed so far that factors will always appear in pairs like this. Right? Now my question is, find the 7th largest factor of this number 6,000. How to find? It may be tedious task, it may look like so, but it is not that. So what we need to see? We need to find the 7th smallest factor, right? What will the smallest factor of this number? Obviously it is going to be 1, right? 1 divide this number 6,000. 2 also divide this number. 3 also divide this number, right? 4 also divide this number. 4 will divide this number, right? 5 will also divide this number. 6 will also divide this number. But after 6, which number will divide this number? 7 doesn't divide this. But is this number divisible by 8? Yes, that's correct. I can see many of you, Anshika, Ronit. Yes, that's correct. So 8 divides this number completely, right? So 8 is the 7th smallest factor of this number. And now 7th largest factor, when I'm asking you, it is going to be just partner of this number or pair of this number. And how to get that pair? We know that 8 multiplied with the that 7th largest factor will give me the product 6,000, right? So basically answer, what we are looking for is simply 6,000 divided by 8, and that you can do very easily. So it will be 8 7s are 56, 4 8 5s are 40, 750. So that is the correct answer. Many of you have written that. Is it okay? Understood? So that's the basic property of factors we have seen so far, that all the factors appear in pair for every number, whether number is a square number or not, that does not matter. Right? Good. Let's proceed further. I'm erasing this. Okay, this is one property of factors. Now some of you were telling that number of factors of a number will always become even because they are appearing in pairs. But dear student, I could see one comment which I was saying was being posted repeatedly. उसमें यही लिखा था, for square numbers this will not happen. One more question. Don't worry, there are unlimited number of questions. So right now, try to keep learning. We'll be doing many more questions. So this will happen. Let me write one more number. Say which number I should write. Maybe if I'm writing say 420. Find out what will be the fifth. Fifth will be too easy for you. Maybe eighth. What will be eighth largest factor for this number? Find out 420. Fourth largest factor, eighth largest factor for the number 420. Yes, Titli, we have not yet talked about the total number of factors. We will come to that. Now, first find out this. Okay, I have got many answers. Kavya, Ayush, Lavanya, Shubhodweep, Athira. All of they are saying 42. Ayush. Okay, how to find? Same method as we did earlier. The eighth largest factor is going to be just pair of or partner of eighth smallest factor. And smallest factor find out karna is quite easy, right? So smallest factor of this number is 1. After 1, 2 also divide this number. 3 also divide this number. 4 se bhi divisible hai. 5 also divide this number. 6 will divide this number, yes or no? Yes. And this number is also divisible by 7 this time, right? But if this number is divisible by 8, no. 9 doesn't divide. Yes, 10 is the 8th smallest factor. That's correct. So 10 is the 8th smallest factor, and 8th largest factor is simply going to be the partner of 10. So you tell me 10 में क्या multiply करें so that the product becomes 420. It's quite easy, 42. Right? And most of you have already found that. Wonderful. ठीक है. तो हम आगे बढ़ते हैं. So next I was talking about number of factors. Will it always be even? So answer is of course no. In case of square numbers, if I talked about let's say maybe 49 or maybe 36, 36 is a square number as all of you know. So let's find out the pairs. So first factor is going to be 1 and its partner is going to be 36, right? Smallest one and largest one. Then 2 is having a partner 18, isn't it? Same way after 2, 3 also divide this number and partner of 3 will be 12, right? 12 also is a factor. 4 and 4 will be having a partner 9 because 4 also divide this number, and when we divide this number by 4 we'll be getting 9, right? And after 4, 5 does not divide this number, 6 divide this number. And what is the pair of 6? What is the partner of 6? It is 6 only. But we are not going to write 6 2 times, right? Yes, 6 and 6 will be a pair. Wonderful. So if you count the number of factors for this number now, it comes out to be odd because there are 2 factors, then 2 more. These are 2 factors, then 2 and 18, 2 more factors, then 2 more factors, 2 more. But its square root is having same number as its partner, right? So and that will be written once only. So what can we conclude from here? That for a square number, number of factors is going to be odd number, right? Wonderful. So far this part is done. Yes, perfect square. That's perfectly all right, Tanya. Perfect square numbers will have odd number of factors. Is this point clear to everyone? Right. Okay, let's proceed now. So far we have discussed that square numbers will have odd number of factors and the numbers which are not squares will have even number of factors always, right? Anuradha is saying, please repeat again. See, Anuradha, we had discussed prior to this that all the factors for any number are going to be in pairs. And what is the property of that pair? That the two numbers in that pair multiplied, when they are multiplied, they give the number only. So for 36, 1 and 36 makes a pair because their product is 36. 2 divides this number and pair of 2 or partner of 2 will be 18 because 2 into 18 is again 36. Same way 3, 12 is a pair, 4, 9 is a pair. And after 4, 5 does not divide but 6 divides this number. And pair of 6 or partner of 6 is going to be 6 only. That's true. But while writing the all factors, we are going to use 6 once only. So that was the conclusion here. In case of perfect square, square root is always going to be a single factor, which is not having any partner written here. So for square numbers, total number of factors will be odd, and for non-square numbers, which are not square numbers, there will be even number of factors, right? Okay, let's proceed further. Okay, okay. Before I proceed further, can you find out product of all the factors? Like in this case only, right? In 36 to 36, this product is having value 36, again 36, again 36, again 36, and but this is 36 raised to power 1 by 2. Right, this is 36 power half. So 1, 2, 3, 4 and 4 and half. So product of factor of this number 36 become 36 raised to power 4 and half, or basically 9 by 2. Isn't it? Yes, exactly. That's perfectly all right, Vidushi. Yes. So yes, in general, that's many of you are concluding also. So what is the shortcut or what is the direct result? That product of factors for any number is always going to be that number raised to power number of factors by 2. So now it does not matter whether our number was a perfect square or not. If number was perfect square, in that case, number of factors are going to be even and we are going to get complete number of pairs, whole number of pairs, right? And if number was a perfect square, as in this case, in that case, there is going to be one number left remaining in between. So that does not make any difference. Why? Because this is half pair, right? This 6 can be written as 36 raised to power 1 by 2. ठीक है ना? Let's take another example to understand this. Yes, many of you have understood, but some of you might be having doubt. I'm explaining again. Mudit, I'm taking one more example. Let's take these two numbers only. Okay, let's take these two numbers only. We talked about 60 and we talked about 36. I'm taking these two examples only. Same examples, same numbers I'm taking so that we can understand easily. For 60, the factors were 1 and its partner 60, right? So 1 into 60 will give me 60 only, right? Next factor was 2, its partner was 30. So their product is again 60, right? And then 3 and 20 is a pair. Then we have 4 and 15, that's a pair. Then we have 5 and 12, that's a pair. Then we have 6 and 10, that's a pair. After that, do we have any other factors for number 60? No, because 7 does not divide 60, 8 does not divide 60, 9 does not divide 60. We got complete number of pairs. So there were total 12 factors and 6 pairs, and each of whose product is equal to 60. 60. This is also 60, and this is also 60. So total how many pairs are there? 6 pairs. Why? Because 12 factors were there, right? So can we say that number of pairs are 12 by 2? Yes, of course. So product becomes 60 multiplied with each other 6 times. That is 60 raised to power 6 or 60 raised to power 12 by 2. Right? So 60 was our number, 12 is the number of factors and divided by 2 because that many number of pairs are there. Exactly as we had written in this box. Right? And same thing we observed for the number 36 as well. Let me write it again. For 36, our first factor was 1 and its partner is 36. Right? So their product becomes 36. And next was 2 and its partner is 18. Next pair will be for 3 and 12. Next will be for 4 and 9. After that, we have 6 only. Right? Because actually pairing was to be done with 6 and 6. So pairs are there. But that is half pair now. So this product is 36, this product is 36, this product is 36, this is also 36, and this 6 can be said to be 36 raised to power 1 by 2, isn't it? So when they are multiplied together, so that leads to the product as 36 raised to power 9 by 2. Again, 36 is the number, 9 is the number of factors by 2 because that many pairs are there, right? So that's why I said the product of factors will remain always this number raised to power number of factors by 2, whether number was perfect square or not. Clear? Yes, Vedant, we are coming to that, how to get total number of factors for any number. That's the next part. But before that, we are understanding properties. We will come to that. Till this point, is it okay? To find a product of factors for a large number, what we need to find? We need to find number of factors. That's what other student was also asking. We are coming to that. So have patience for that, wait for that. But how to find product of factors, that we have understood. That is number raised to power number of factors by 2. So now, obvious question is, how to find this number of factors? We are coming to that. Okay, so should I move further? Okay, I'm proceeding further now. Let's see what's there in store for us. I'm erasing this. Okay, here are some properties written. Let's read them out. The first point says, if anybody is still having any doubt, you can certainly repeat the same video later, or also we have explained this in the conceptual videos also. So, and also there's one more opportunity available, peer help, right? Peer help. Let's proceed further for now. A perfect square will have odd number of factors. We have just done that. An imperfect square, or basically which number which is not a perfect square, will have even number of factors. We have discussed that. Product of all the factors of a number is always going to be number raised to power number of factors by 2. That also we covered. And number of ways in which n can be written as product of 2 factors is number of factors by 2. That's one more thing. See, what is that? Let's take an example of same numbers. If we were talking about 60, so 60 was having 12 factors, right? And we found their pairs as, I'm writing them again, 1 times 60, 2 times 30, 3 times 15, 4 times, have I made any mistake? Yes, it is 3 times 20, sorry. 4 times 15, 5 times 12, and 6 times 10, right? Now, what is our target here? We want to write a number of ways. We want to find the number of ways in which n can be written as product of 2 factors. So here we have written 60 as product of 2 factors, right? This is one way, this is second way, this is third, fourth, fifth, and sixth. Is there any other way to write 60 as product of 2 factors? Certainly not. See, don't get confused in the negative factors. As I said earlier, right now when we are talking about factors, so we are talking only about the positive factors, right? Yes, exactly. So it simply comes out to be number of factors divided by 2. So as it is mentioned here. So if n is not a perfect square, what will happen in case of it is a perfect square? So for example, same number 36 if you talk about. So for 36, there were 9 factors, right? So first pair would be 1 times 36, then 2 times 18, 3 times 12, 4 times 9. But this time, 6 times 6 will also be considered, right? This will also be considered. That's why there were number of factors were 9, but now there are 5 ways. So what we need to do? So number of factors plus 1 divided by 2, if n is a perfect square, right? So that becomes the shortcut for this, if you wish to use. Otherwise, you can always use your basic understanding. Okay. And a number is prime if it is not divisible by any prime number less than root n. We have already done this part in the last class. Till this point, is it clear? Any doubts? Nandini कह रही हैं repeat. What about others? खुशी is okay. Varsha is also saying repeat. अरे ये ग्रुप की बात बीच में कहां से आ रही है? Clear. ठीक है. 2-3 students are having doubts. Some are saying not clear. Repeat the last point. Last point, Neha, we did it yesterday. A number is prime if it is divisible by any prime number. A number is not. Yes, a number is prime if it is not divisible by any prime number less than root n. We did this topic in yesterday's class when we discussed about prime numbers. So no point in discussing it again. So far we have discussed these first 5 points. I'm repeating this one point, this last 2 points again because we had already done this thing. So here our target is to find the number of ways. मैं इस वाली बात को दोबारा बता रहा हूँ. ये 4th and 5th points. So we are talking about this 4th and 5th point again. See, in this 4th and 5th point, number of ways in which n can be written as a product of two factors. हम कितने तरीके से एक नंबर को दो नंबर्स के प्रोडक्ट के तरीके से लिख सकते हैं. So I've taken the same example of the numbers 60 and 36. तो अभी 60 को if I want to write as product of two numbers or two factors, so जितने इसके factors हैं, there are total 12 factors. We are seeing it for last few minutes. So total 12 factors हैं, and all factors are different. So 12 factors can be paired in 6 ways, right? And these are the ways: 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. There is no other way to write 60 as product of two factors, isn't it? So total number of ways कितनी है? How many ways are there? How we are going to do? It's simply number of factors by 2, right? जितने भी factors हैं उसको half कर देंगे. We are going to get the number of pairs, number of ways, right? But what if number was perfect square, as in the case of 36? So in that case, what is going to happen? Now the 6, which was square root of this, so that is also having a way now. We can write this 36 as 6 times 6, right? So considering this 6 2 times in a way, so total number of factors, total number of pairs becomes 5. So how did we get 5? So we can modify our result like this. So number of factor plus 1. ये plus 1 किसके लिए किया? For the square root, right? 36 का square root तो 6 था, तो एक बार और 6 को include अगर हमने कर लिया, so we are getting total number of factors plus 1, that many factors now, right? And divided by 2, that will give us the number of ways to write this. That's the only thing. So if you want to remember this, that's fine, there's no problem. And if you find any difficulty in remembering this, there's no need also. You can always do this thing. You need to calculate, of course, number of factors and then write, right? Now Sandeep is asking, Snehadeep, how to check if a number is a square or not? Good point. Let's check that. देखते हैं. And this thing will be actually covered in the next topic now when we are going to calculate number of factors. So I think we should proceed further with this question. We will use the same method that we do for any perfect square. Yes, it's same. Whether number is square or not square, that is same thing. There's no difference. Last 6 point, please explain. 6 point, beta, I have already told. This is regarding prime numbers, which we discussed in the last session in detail. We discussed this point in the last session. You can check there. Okay, let's proceed further. Okay, now the important question, how to find number of factors? Many of you are asking that. How to find number of factors? Mayank, क्या छूट गया? Repeat point 3. What's that? Let me see. 3 we did na baba. We did this in so much detail. Product of all the factors of a number is number raised to power number of factors by 2. We did this part in too much detail. The same thing. Okay, now how to find number of factors? So what we need to do, now understand it carefully, although many of you have already done that. कई लोगों को formula भी याद है. I can see some formulas in comments. Yes, if you know already the formula, don't worry. As I have said already, I am not interested in remembering or teaching formulas. There can be n number of questions. We need to understand the basics. So by understanding the basics, then you can apply the formula directly, no issues. Okay, so to find number of factors of a number, first step is to write the number in its prime factorization. I repeat, we need to write the number in its prime factorization. For example, if I'm having a large number, let's say 14,400. Let's say this is the number 14,400. So what are the factors of this number? How many factors divide this number? How many positive integers divide this number? To calculate that, first step is to write this number in its prime factorized form. Okay, so please find out its prime factors and tell me in the comments. Yes, Chintan, there's a perfect way. 144 times 100, not 1000. It's 14,400. So 144 into 100, that is the starting step. But we need to write it in its prime factorized form. Okay, Janab says 2 power 6, 3 power 2, 5 power square. Let me see. Okay, 2 power 6, 3 power 2, 5 power 2. Many of you are saying that. Okay, so we have understood this also in one of the conceptual video, how to find out prime factorization faster. So Chintan, I guess, if I'm not forgetting the name, so Chintan started nicely. 14400. I can break it like this. It's 144 into 100, right? Now 100 is 10 square, or basically 10 into 10. And this 144 is 12 square, that is 12 into 12. And we know that 12 means 4 times 3, that is 2 square into 3. Again, we have 2 square into 3. This is 2 into 5. Again, 2 into 5, right? So I just prime factored without writing anything. So total, how many 2's are there? 2 and 2, 4 and 1, 5 and 6. So basically, this is 2 raised to power 6, right? Then 3 power 1 and 2. This is 3 square. And powers of 5, we are having here 1 and 1 more. That is 5 power 2, right? That is the prime factorization of this number. This point is clear? That is was the first step. If we want to find out number of factors for any number, we need to write the number in its prime factorized form, and that is the prime factorization of this number. 2, 3, 5 are the different prime numbers. When we are saying prime factorized form, so the base numbers must be different prime numbers, right? It must be different prime numbers. Okay, let's proceed further. The next step now. Am I erasing this part? Okay, before finding its number of factors, as many of you have already done that, but let me ask you, is this number a perfect square number? Is this number a perfect square number? Yes or no? Tell me in the comments. Many of you are telling the answer number of factors, because you already know that. I told you this thing yesterday also. What you already know, you know. But if you are not gaining anything out of the session, then you will remain wherever you were. Yes, you are saying perfect square. कैसे पता लगा? How do you get to know it is a perfect square? How do you get to know? आदिल अभी भी फैक्टर्स कैसे निकालने उसका मेथड बता रहे हैं. We will discuss that. As you know, many others also might know. कैसे पता ये perfect square है? Yes, because the powers are even. Wonderful, Ria, and others are yes, even powers. Suhani and others are also saying that. Good. Powers is even. Ayush, that's yes. Karthik. Good. See, because the powers are even, तो ये perfect square है. क्या इसका रट्टा मार लें क्या? Should we memorize this? No. See, perfect square means when a number can be written as product of two equal numbers, right? So can we divide all the prime factors of this number in two equal groups? Yes. 2 power 6. If I make two brackets, so they should contain the equal quantity. So 2 power 3 can be put here, 2 power 3 can be put here, right? 3 power 2, so 1 3 can be put in this first bracket, 1 3 can be put in the second bracket. 5 power 2, that can also be divided equally in the two parts. So basically this number can be written as product of two equal numbers, which confirms it is a square number. So do we need to write this always? Not required. Why? Because we know that because powers are even, so it can be certainly broken down into equal parts, right? So that confirms this is a perfect square number. Understood? One of you were asking, some of you were asking, how to check whether a number is perfect square or not. So prime factorization is the key point. Okay, next question. Swati Tushar, you are saying no. What's no? Is this point clear? Yes. Good. Now tell me, is this number a perfect cube? I'm repeating my question. Is this number a perfect cube? मैं कह रहे हैं नहीं आया. Don't worry. अभी बात करते हैं. I'm here only. I'm not rushing up. Now answer this question. Is this number perfect cube? Okay, many of you are saying no. Samprati, Arnab, Apurva, Soham, no. कैसे पता लगा? How do you get to know that it is not a cube number? See, now cube number means this number must have been able to be written as product of three equal numbers, right? Yes, exactly. That's a perfect point, Shubhangi. Wonderful. Powers should be multiple of 3 so that we can divide each prime numbers along with its power in 3 equal parts, 3 equal groups. So 2 power 6 can be broken down in 3 parts, right? 2 power 2 each. 2 power 2 पहली bracket में 2 power 2, 2 power 2. But 3 power 2 we cannot put down it in 3 equal parts, right? Because power is 2 only. If it had been 3, then we could have put 3 one time here, one time here, one time here, right? So because powers are not multiple of 3, so this number is not a perfect cube. Understood? Power should be multiple of 3. So exactly same way in the last part when we discussed कि perfect square है कि नहीं है, so power should be multiple of 2 or even powers basically. Clear? Yes, Shankha can't be distributed in 3 groups. Wonderful. That's perfectly fine. I hope this is clear to everyone, right? Okay, let's proceed further now. So now how to find number of factors. So I'm not giving you formula directly. Formula many of you already know. But tell me one thing. Will 2 divide this number? Yes or no? Please write in comments. Will 2 divide this number? Yes, of course. 2 square will divide this number? Will 2 square divide this number? Kadambari is asking, is it possible to have some number which is square as well as cube? Yes, of course. अगर powers जो है 2 का भी multiple है, 3 का भी multiple है, then it is both, right? We'll come to that later. I forgot the name. Yes, this is divisible by 2 square also. So what is the highest power of 2 which will divide this number completely? Is it divisible by 2 power 7? No, 2 power 6 तक divide होगा. That's correct, Chintan. Because this number contains maximum power of 2 as 6 only. So this is divisible by 2 power 6, but it is not divisible by 2 power 7 or higher powers, right? So this number is divisible by 2 power 0 or 2 power 1 or 2 power 2, 3, 4, 5 or 6. But not more than that. Not more than that, right? So with any power out of these, with any number out of these, if I divide this number 14,400, it is divisible. Akshay, please keep your doubts for the last. If any of you are having doubts, I said this earlier also, I'm repeating it. So I will give you last 15 minutes for that only. So please keep your doubts. 2 power 0 means 1. Yes, that's perfect. 2 power 0 means 1. So 2 power 0 will divide this number. 1 will divide this number. 2 also will divide this number. 4, 8, 16, 32, 64, right? But 128 does not divide this number. Till this point, is it okay? Gunjan is saying, why take 2 power 0? Because 2 power 0 divides this number. I'm just looking for those numbers which divide this number perfectly among the powers of 2. So starting from 2 power 0 up to 2 power 6, all these 7 numbers, so 7 values, 7 numbers basically, they divide this number perfectly, right? Let's move further. Same way if I check for powers of 3. So what is the smallest power of 3 which will divide this number? Again 3 power 0, right? Diksha, 2 power 0 का मतलब 1 होता है ना? 1 divides this number. So I'm just writing which powers of 2 divide this number. Now I'm writing which powers of 3 divide this number. So as we did for 2 powers of 2, same way 3 power 0 divide this number completely, 3 power 1 divide this number completely, and 3 power 2 also divide this number completely, right? Kya 3 power 3, that is 27. Will 27 divide this number? Yes or no? Of course no, because highest power of 3 contained in this number is 2. Right? Okay, before proceeding further, tell me one thing. Okay, proceed. Let me proceed further. मैं इससे पहले power of 5 पे जाऊं, उससे पहले मुझे एक बात बताओ. Will 2 power 0, let me write it here. I'm using different color. Will 2 power 0 into 3 power 1, 2 power 0 into 3 power 1, their product, will this product divide this number? Yes or no? I repeat my question. Will 2 power 0 into 3 power 1, will this product divide this number? Yes or no? Green color. It will divide, right? Yes. One more. Will 2 power 3 multiplied with 3 power 2, that is 8 into 9, 72. Will 72 divide this number? Yes. Right? Will 2 power 6 into 3 power 2, will that divide this number? Yes. Are you getting what I wish to say? Basically, each of these combinations are going to divide this number. Right? So far, I have not considered powers of 5. Now, before proceeding further, tell me, can you estimate total how many combinations we can form? With 2 power 0, I can multiply 3 power 0, that will make 1. With 2 power 0, I can make 3 power 1, that will make 3. With 2 power 0, I can multiply 3 power 2, that will make 9. So 3 combinations, 3 more, 3 more, 3 more, 3 more, 3 more, 3 more. How many times 3? 7 times 3. So far, we have formed 21 combinations. Each of this combination of product of these numbers is going to divide this number completely. Is it understood? Wonderful. Yes, Chintan, now you are reaching up to the conclusion. That's fine. Excellent. Till this point, is it understood, everyone? We are having more than 800 students here connected. Formula रट्टा मारना बहुत आसान है. Good. So there are 21 combinations, and each of the combination is a factor for this number. Acha, before proceeding further, tell me, have we repeated any combination? क्या कोई number repeat होगा क्या? While writing all the 21 combinations, will there be any repeated number? Of course not. 1 into 1, 1. 3, 9, 2, 6, 18, 4, 4 into 3, 12, 4 into 9, 36. Then 8 into 1, 8, 8 into 3, 24, 8 into 9, 72, and so on. No number will repeat, right? So total 21 factors are there so far. Now for each of these 21 combinations, how many powers of 5 we can take? 3 powers again, 5 power 0, 5 power 1, and 5 power 2. And each of these 21 combinations can be clubbed with any of these 3, right? So total how many combinations or how many factors will be there? It is going to be 7 into 3 into 3, which is 63. Is it okay? अभिषेक कौन सा रिपीट हुआ भाई? Some of you are saying कि 1 रिपीट हुआ. कौन सा रिपीट हुआ? 2 power 0 into 3 power 0, that was 1. उसके अलावा 1 कहां बनने वाला है? Never. 2 power 0 into 3 power 1, that was 3. This 1 into 9 was 9. Then 2 into 1 was 2. So no number is being repeated. Yes, 1 into 1. Good. So total 63 factors. Now let's come to the shortcut part. So how we get this? How did we get this 7? Because power 0 was also there. So 6 plus 1. Same way, how did we get this 3? This 2 plus 1. Right? And same way, how did we get this 3? This 2 plus 1. The shortcut many of you had written already. Let me write it again. So if you are having a number, so first step is to write it in its prime factorized form. So that means different prime numbers with their respective powers. So let's say P1, P2, P3 and so on. There can be more prime numbers as well. And now whatever is their power, let it be A, B, C and so on. So number of factors will be how much? It is A plus 1 multiplied with B plus 1 into C plus 1 and so on. Right? That becomes the number of factors. Clear? So that was the formula. Many of you are already writing in the comments. So formula is perfectly fine. So but we have tried to understand that why it works, how it works. Yes, of course, and product of factors we already discussed. So product of factors is basically number raised to power number of factors by 2. Okay? Till this point, any doubt? Before I proceed further, I wish to check if there is any doubt so far. You can ask. Kanish is saying no doubt. Mayank in between I'm seeing a repeat. Which point is not clear? Mayank, please write clearly. I'm seeing your comments. Aratrika says clear. Tanvi Yadav, no doubt. Samriddhi, no doubt. Good. If anyone is having any doubt so far, you can write down now. Before I proceed further, I wish that there should not be any doubt remaining. Khushi is saying, why not number of factor plus 1 by 2? Where number of factor plus 1 by 2, beta? Product of factors to be seen, na? We had discussed that already. Whether number is perfect square or not, it is always number of factors by 2. We took the example of 60 as well as 36. Dhruv is asking, why did we take only 2, 3, 5? That was a prime factorization, bhai. The number may have other prime numbers also. Number may have single prime number may have more than 10 prime numbers. So whatever number of prime numbers may be there. Okay. Any doubt? No. Mayank is asking, repeat last point. Last point, so we have just concluded this. See, here we found all combinations. I'm repeating again. Listen, what we did, I'm repeating all the steps, how to find number of factors. I'm repeating. Yeah, so most of you it is clear, but some of you those who are having doubts, I'm just repeating, see again the process. So whatever number we are having, first step is to write the number in its prime factorized form, right? So in this case, it was 2 power 6 into 3 power 2 into 5 power 2. And we saw the whole procedure, how it is working, that power of 2 can vary from 2 power 0 to 2 power 7, 2 power 6. So total 7 different values, starting from 0 to 6. They can be there which divide this number. So that's why one extra power because of power 0. Same way for 3 power 2, 3 power 0, 1 or 2. These are the 3 powers of this number which divide the given number. Same way there are 3 possibilities for power of 5. And their combinations, that is their product, 7 times 3 times 3 was total number of factors, right? So now to conclude this in fast or in a short method, what we did. So if n is any number and this is its prime factorization where P1, P2, P3 are different prime numbers with their respective powers as A, B, C and so on. So number of factors is simply this power plus 1. And why it is plus 1 that we have already seen here. So this is A plus 1 into B plus 1 into C plus 1 and so on, right? Okay, before I proceed further, here's a question for you. Same, tell me the number of factors of 2 power 3 into 3 power 4. Fast. The simple question. Tell me the number of factors. 2 power 3 into 3 power 4. Yes, it's 20. Khushi, you are again asking product of factors, number of factor plus 1 by 2 क्यों नहीं है? We discussed this, beta. Number of factors by 2, we saw the last examples. Plus 1 क्यों कर रही हो आप? Is there any reason? Don't go by the formulas. There's a difficulty with the formula. You don't understand that. Yes, 20 is 4 times 5, right? This is 3 plus 1 into 4 plus 1. 2 and 3 both are prime numbers and this is their powers. So that comes out to be 4 times 5, that is 20. Perfectly all right. Okay, next question now. Jaldi say. Tell me the number of factors of 2 power 3 into 3 power 4 into 4 power 5. Fast, please. Don't do any mistake. Number of factors of 2 power 3 into 3 power 4 into 4 power 5. Many of you are saying 120. See, that was the original trap. That was the trap which I was looking for. And all of you are trapped in that. Oh, I can see one answer here. I missed that comment. One student wrote the correct answer. Otherwise, most of you are writing 120. It's not correct. 120 is not correct. 120 is not the correct answer. Yes, Aditya is writing 70. That's perfectly fine. Yes, exactly, love. 4 is not prime. Good. Many of you have found the right answer now. Understood? The drawback of just applying the formula without understanding the basics, that's a trap. Yes, जाल सही word लिखा यश. जाल में नहीं फंसना. See, here it appears like to be a prime factorized form and directly you have applied the formula 4 into 5 into 6, but that's wrong because 4 is not a prime number. So first step is to write this number in its prime factorized form. Okay, 2 is a prime number, 3 is a prime number, but 4 is not prime, right? So 4 means 2 square. So 4 power 5 becomes 2 power 10. So basically it becomes this 2 power 10 and 2 power 3, total 2 power 13, right? Multiplied with 3 power 4. So that is the number. So number of factors comes out to be 13 plus 1 multiplied with 4 plus 1. So then this is the same step, 14 times 5, which is 70. So 70 is the right answer, right? Exactly, that was the purpose. Okay, so far we have understood what are the factors, what are their properties. They appear in pairs. There are even number of factors for perfect the numbers who are not perfect squares, and for perfect squares there are total odd number of factors, right? Meanwhile, that time also already we saw that product of factors is always number raised to power number of factors by 2, and then we discussed how to find number of factors. So we understood the process, and of course conclusion was already known to you that if we write the number in its prime factorized form, then we can easily calculate the number of factors like this, right? Anguri is asking what was the question. हाय सिली वाला मिस्टेक हो गया. यस श्रेया, मिस्टेक नहीं करना है. क्वेश्चन ये कोई पूछ रहा है बीच में. भास्कर सिंह 13 कैसे? ओके, लेट मी गिव यू वन मोर क्वेश्चन. आप फिर से जाल में फंसना चाहते हैं तो जाल की कमी नहीं है. लेट मी क्रिएट सम स्पेस हियर. आई एम गिविंग यू वन मोर क्वेश्चन. एवरीवन जो जाल समझ चुके हैं दोबारा ट्रैप में मत फंसिएगा. एंड दोस वाज स्टिल वंडरिंग कि क्या क्वेश्चन था, सी इट हियर अगेन. यू हैव टू टेल मी द नंबर ऑफ फैक्टर्स. फाइंड द नंबर ऑफ फैक्टर्स ऑफ 2 power 3 into 2 power 4. Tell me the number of factors fast. Tell me the number of factors for this number. कुसुम कह रही है कौन फंसेगा. अभी देखो बच्चा फंसेंगे. I'm waiting for your comments. Here is the question. If you have not seen it, question is you have to tell me the number of factors of 2 power 3 into 2 power 4. See, Karthik is saying 20. Vivek is also saying 20. I'm not speaking of the right answer. Many of you have written the right answer as well. But some of you are doing mistake also. 8 is the correct answer. See, don't rush to the formula directly. You are going to be trapped. Don't get trapped. नहीं भाई 8 सही है. Aditi, 8 is correct. See, 2 power 3 into 2 power 4, we need to find number of factors. So, first step was to write the number in its prime factorized form, where number has been written as product of different prime numbers with their powers. But 2 and 2, they are both prime numbers, but are they different? No. So, prime factorization for this number is actually 2 raised to power 7. And number of factors now, it is simply 7 plus 1, which is 8. And most of the students, I'm happy with this, most of the students have wrote the right answer, but few glitches were there. Okay, so don't get trapped in these types of easy questions. Yes, 20 was the wrong answer. Cavalya, thanks for giving us the wrong answer. ठीक है, हम आगे बढ़ते हैं. Okay, let me proceed further. I hope there should not be any doubt so far. I have a lot of questions, and I'm sure many questions you are going to discuss in that application classes also. Okay, Aditi has written a long paragraph sentence. Very nice. I'm proceeding further now. Let's see what's there. Okay, here's the conclusion written. So let me come this side. It says, for number n, p1 raised to power x, p2 raised to power y, p3 raised to power z, and so on, where p1, p2, p3 are prime numbers. Clear it. It is distinct or different prime numbers. And x, y, z are natural numbers, which are basically their powers. Then number of factors of this number n is given by that x plus 1 into y plus 1 into z plus 1 and so on, right? So we had just discussed that, right? Let's proceed further. Okay, here are some questions for you. So quickly answer them now. First question, answer please. Ruchika is asking, how do you find sum of factors? Ruchika, we will come to that. Wait, I will come to that. Srinivas एक और trap वाला question मांग रहे हैं. Don't worry, I will come to that. First, answer this first question here. Okay, 336, 356. Don't do any mistake in multiplication. Okay, it's 336. So how do we do it? It's very easy. So 2, 3, 5, all the three are prime numbers. They are different prime numbers. So this is the number in prime factorized form only. No trap, right? No trap involved. So total number of factors is simply 7 plus 1 into 6 plus 1 into 5 plus 1. Directly, I could have written 8 into 7 into 6. We just need to multiply them. Okay, let's proceed further. Find the total number of odd factors. How do we find this? See, when it is asking about odd factors, so basically, we do not wish any power of 2 to be in the number, right? Number should not be multiple of 2, right? So only 2 power 0 can be considered while considering combinations. Let me write again. See, combination of these numbers were, this is 2 power 7 into 3 power 6 into 5 power 5. So when we were saying 8 possible values for power of 2, so they were 2 power 0, 2 power 1, 2 power 2, up to 2 power 7, right? But if I'm looking for odd factors, in that case, this 2 power 1 up to 2 power 7, these powers are not to be taken. Right? Because if number becomes a multiple of any power of any non-zero power of 2, then it is going to become even. That means there is only one possible value for power of 2, that is 2 power 0. Or in other way, we can also say, we leave that part. And I leave that part, only consider this one. Right? So the answer comes out to be 7 times 6, 42. And I can see that many of you have already written that in comments. Right. Okay, before I proceed further, इसी question में अगर मैं आपसे ऐसा पूछता हूं, find the total number of factors which are multiple of 3. Let me write here, multiple of 3. Can you find out the answer? How many factors of this number, same number, are multiple of 3? Please write your answer. Hamimansha, I'm on second question only. How to understand the second question? Second question was asking about odd factors, so we have removed powers of 2. Basically, only 2 power 0 can be considered, no other power of 2 can be considered. So it becomes basically 1 into 7 into 6. There is only one possible power of 2, that is 2 power 0, which can be considered while making combinations. And for powers of 3 and 5, there is no issue. All 7 powers of 3, that is 3 power 0 से लेकर 3 power 6 तक. And same way, all 6 powers of 5, that is 5 power 0 to 5 power 5, they can be considered. That's how 42. Now my question is, multiple of 3, the factors which are multiple of 3. Now tell me, if I wish my factors to be multiple of 3, what are the constraints? Is there any constraint on powers of 2? Yes or no? There is no constraint. You are guessing 7. 7 is not correct. Beta, बहुत सारे बनेंगे. There are many multiples of 3 numbers. There will be many multiples of 3. Now try to understand. You are guessing maybe this, maybe that. No need to guess. Let's understand. Let's try to understand clearly. Now no need to write. Please see here on the board. So 2 power 7 into 3 power 6 into 5 power 5. This is our number. I wish that my factor must be multiple of 3. So when I'm saying it should be multiple of 3, it means the number must contain at least 1 power of 3. Isn't it? Number must contain at least 1 power of 3. Right? So that means when we are considering power of 3, so we need to not to consider 3 power 0. Right? 3 power 0 can't be considered. All other things are allowed. Right? All other things are allowed. So 2 power can be considered from 0 to 7, total 8 combinations. For powers of 2, for powers of 3, it will be only 6 because 3 power 0 can't be considered. Other than that, all are valid. And for powers of 5, again, all 6 combinations can be considered because powers of 5 can be anything from 0 to 5. ठीक है ना? So we just need to multiply that and this is going to be our answer. You can multiply that and find this कितना बनता है? So this is 8 times 36. 36 का double is 72. 72 का double 144. 144 का double 288 is right. I could see 288 in some of the comments. Yes, 288 is correct answer. ठीक है? Gunjan is asking why others are valid. See Gunjan, 2 power 5 into 3 power 2. Is this number multiple of 3 or not? Yes or no? I'm repeating, don't worry, those who have not followed properly. Now again, be focused. 2 power 5 into 3 power 2. Is it multiple of 3 or not? Just tell me yes or no. Is this number multiple of 3? Yes or no? Yes, it is multiple of 3. Acha, if I make it 2 power 6 multiplied with 3 square, is it multiple of 3 or not? It is still multiple of 3. Acha, if I multiply in this, say 5 raised to power 3 also, now is this number multiple of 3? Yes, it still is. So it does not matter what is the power of 2 or what is the power of 5 contained in this number. What determines, what tells us that whether this number is multiple of 3 or not? So we should look for the powers of 3, right? Whether this number contain non-zero power of 3 or not. That's why I have removed 3 power 0 wala case. Right? I have removed the 3 power 0 wala case. That means in this factor, in this number, when we are considering factors which are multiples of 3, so which power of 3 are valid? Except 3 power 0, all the 6 cases can be considered. Which 6 cases? That is 3 power 1 or 3 power 2 or 3 power 3, 4, 5 or 6. But while considering powers of 2 or powers of 5, we could use their all powers, all cases. Excellent question. One of you, Ananya, is asking, multiple of 10 hoga to? Please answer this question. Good question, Ananya. I'm erasing this part. Tell me how many factors of this number are multiple of 10? Multiple of 10. बताइए. Yes, Anguri, here's another question. Multiple of 10. Now, what is the constraint? Think over that. Nasimha says, why 3 power 0 not considered? सोचो भाई, अगर नंबर के अंदर 3 की पावर 0 ही है, तो will that be multiple of 3? It will not be. Right? That was the case. If I want multiple of 10, that means I need at least 1 power of 2 and 1 power of 5, right? So 2 power 1 तो लेना ही है कम से कम. तो 2 power 0 will not be considered. It is 7 ways to select a power of 2. Similarly, for powers of 5, I need at least 1 power. So 5 ways to select a power of 5. But for powers of 3, there is no constraint. I can consider all the 7 cases. So that's perfectly fine. Many of you have written that. 7 times 7 times 5. Right? So 49 times 5, that comes out to be 245. Fine. Okay, let's proceed further. There are many more questions in these pages. So we'll explore more things. Yes, 245 is correct answer. Okay, I'm moving further for the next question. Here's some more. Find the total number of even factors. Please find out total number of even factors. How to go about this now? Yes, 292 is one answer I'm looking for. Prasoon. 294, okay. See, when we are talking about even factors, that means we need to consider power of 2, right? So 2 power 0 won't be considered. All other cases will be there. So for powers of 2, there are 7 possible ways. 2 power 1, 2 power 2, 2 power 3, 2 power 5, 6, 7. For powers of 3, there is no constraint. So all the 7 cases, including 3 power 0 to 3 power 6. And same way for powers of 5 also, all the 6 cases starting from 5 power 0 to 5 power 5. So that is 7 times 7 times 5. So 49 into 5, that's again 245, right? That would be the answer. Now you are saying 294. Many of you are saying 294, 180. Have I? I did one blunder here. It should be 6 now. Let me correct it. For power of 2, we need to consider 7 cases except 2 power 0, right? For power of 3, it will be all 7 cases. And for power of 5, all 6 cases. Yes, that's true. So this is 49 times 6. That is 294. Yes, 294 is correct. Sorry for the mistake. Yes, 7 into 7 into 6. Okay, next question now. Find total number of prime factors. What is the meaning of this? Prime factors. So when we say prime factors means those factors which are prime numbers. I repeat, when we are talking about number of prime factors, so it means those factors which are prime numbers. So can you tell me how many different prime numbers divide this number? 3 it is. That is 2, 3 or 5. Right? So there are 3 factors, 3 prime factors. All right. Let's move further now. Okay, there are some more questions. Total number of known prime factors. Now that you can easily find by total number of factors minus those 3 prime factors. Multiples of 6. Okay, here's one more question for you. Everyone, please answer this. Multiples of 6. Now for multiple of 6, because 6 is 2 into 3, so we need to consider at least 1 power of 2 and at least 1 power of 3, right? So it will be 7 into 6 into 6. That's correct. Many of you are writing that. So it will be 7 into 6 into 6. You can multiply it and you'll get the answer, right? So 36. 36 into 7 will be, yes, 252. That's correct. Okay, fine. Let's move further. Okay, there are 2 more questions. Total number of factors that end with exactly 10. Here, please focus on this point. Exactly 10. How to discuss this now? Now see, Gunjan is asking, please tell fifth. Fifth to bhi baat ki na? Fifth kaun sa tha? Wait, let me go back. Fifth. Arey beta, number of known prime factors. Total factors kitne the? 8 into 7 into 6. That was total number of factors. And now from this total number of factors, subtract the prime, which are 3, right? And that's it. It was asking about known prime factors, है ना? तो जो prime नहीं है, तो जो prime थे वो हटा दिए हमने, तो that will give you the answer. That was the fifth one. Okay? अच्छा, अब यहाँ पे there's a good question. In spite of known prime, if it asks for composite factors, what will be your answer? Find the total number of composite factors. Will it be same or different? Composite factors, known prime and composite. What's the difference? Okay, you are saying same, some of you are saying different. It's different. It's different. It was again a trap. Some of you are looking for trap question. Yes, Aratrika, wonderful. We need to subtract 1 also. See, when I say composite, all the natural numbers, we discussed about this last time. Among all natural numbers, when we divide them in the category of prime numbers and composite numbers, so beside that, there is one number which is 1, which is neither prime nor composite. So 1 bhi remove hoga. Yes. We can consider 1 nahi, we need to consider 1. Yes, फंस गए जाल में. Okay, anyway, so I hope this is clear. So we are moving further for the next question. Here in the 7th question, it is asking for exactly 1 0. Exactly 1 0. Now please understand, this is an important point now. Exactly 1 0 का क्या मतलब है? Exactly 1 0 when we say, तो number must be multiple of 10, right? But should not be multiple of 100. I repeat, number should be multiple of 10. Multiple of 10. See, multiple of 10 we just did before that, right? Before some time we did this, multiple of 10. But in this case, that's not the requirement. That number should be multiple of 10. It should be multiple of 10, but not multiple of 100. That is the requirement. Is this thing clear? क्या ये बात समझ में आई है? Add का just 2 and 5 जरूरी नहीं है. There can be many things, but 2 और 5 का पेयर जो है वो एक ही बनना चाहिए. So how we go about this? Now the basic way and simplest way, straightforward way is that calculate the factors of this number which are multiple of 10. Calculate the factors of this number which are multiple of 100 and then subtract them. I repeat. So हमें क्या करना होगा? We need to calculate the number of factors of this number which are multiple of 10. ठीक है? Also calculate number of factors of this number which are multiple of 100 and then subtract them. See, the number which is multiple of 100, that is multiple of 10 as well. ठीक है ना? जो multiple of 10 होगा वो multiple of 100 में already included है. I repeat, जो multiple of 100 है, वो 10 का भी multiple है, right? But not every multiple of 10 will be multiple of 100. So we need to subtract this quantity from this one. तो उससे हमें क्या मिलेगा? We'll get those numbers which are ending in, which end with exactly 1 0. तो expression क्या बनेगा? Let's write. So multiple of 10 का मतलब I needed exactly 1 2 and exactly 1, at least 1 2 and at least 1 5. That means that is 7 into 7 into 5, right? That is multiple of 10. Now we need to subtract those numbers which were multiple of 100. So for multiple of 100, 1000 is not required. 1000 is not required, beta. 1000 is not required. We just need to remove those numbers which are having 2 or more than 2 zeros. So we need to subtract those factors which were multiple of 100. तो 100 के लिए हमें क्या चाहिए? For 100, I need 2 power 2 minimum and 5 power 2 minimum, right? So if I'm starting from 2 power 2, so 2 power 2, 3, 4, 5, 6 or 7. There are 6 cases now, right? So for power of 2, there will be 6 cases. For power of 3, there is no constraint. For power of 5, again, I need to start with power of 5 power 2 minimum. So 5 power 2, 3, 4 or 5. 4 cases. So this will give us our final answer, right? Let us simplify this. I wish to take 7 common. So 7 times it is 35 minus 24, which is 11. That makes it 77. So that is the right answer. Yes, 77. ठीक है. Yes, I can see some comments now. Not understanding the question. Yes, that's why I said focus on this question. It is asking about exactly 1 0. Let me repeat it. Yes, I'm repeating that. Don't worry. Yes, I'm repeating it. Don't worry. I'm repeating the logic. See, understand it carefully now. No need to write anything in comments. Please listen. Please listen. Some of you have got it. Many of you have got it. You have got the right answer as well. But still some are confused. So listen carefully. When we are calculating the factors of a number which are multiples of 10, ध्यान से सुनो. When I'm saying the numbers which are multiple of 10, so the numbers which are multiple of 10, how many zeros will be there at the end? सैम पूछ रहे हैं मल्टीपल ऑफ 10 कैसे निकाला? दैट वी डिड ऑलरेडी. मल्टीपल ऑफ 6 भी निकाला था बेटा, मल्टीपल ऑफ 4 भी निकाला था, काफी सारे हमने किए थे. वी नीड एटलीस्ट दैट मच पावर. आई एम रिपीटिंग, जस्ट आंसर माय क्वेश्चन. व्हेन आई एम सेइंग कि इसके वो फैक्टर्स व्हिच आर मल्टीपल ऑफ 10, कोई भी नंबर अगर मल्टीपल ऑफ 10 है, आई रिपीट, इफ एनी नंबर इज मल्टीपल ऑफ 10, हाउ मेनी zeros will be there at the end? Many of you are writing 1 0. Can't there be more than 1 0? If I'm saying a number is multiple of 1, then how many zeros will be there at the end of that number? Yes, that's correct answer, Aditya. It will be greater than or equal to 1. Yes, Chinmay, minimum 1 0. There will be 1 or more zeros. Is it not? Yes, 1 or more zeros, exactly. So we need to be very, very specific. Conceptual understanding is very much required. Before, without that, very easily you can commit mistakes and you can be trapped. Right? There can be more than 1 zeros, but minimum 1 0 will be there. Right? 1 or more number of zeros. But this question is asking about exactly 1 0. That is this question all about. Okay? That is this question all about. So this question is asking about those factors which are having exactly 1 0 at the end. So what we need to do? We need to remove those cases, those factors which were having 2 or more zeros at the end. Right? Which were having 2 or more zeros. And 2 or more zeros kahan milengi? Multiple of 100. That's correct, Vimarsh? Yes. Multiple of 2 zeros kahan milengi? which are multiple of 100, and that's what we have done. So find the factors which are multiple of 10 and subtract those factors which are multiple of 100. Okay. Chike, I think we have done almost all the things which we were to discuss. One thing is remaining, sum of factors. That's although not very much required for CAT, but anyway, we can discuss that also before taking your doubts if there are any. Okay, I'm proceeding further, and one more thing which I wish to discuss is that you can do very easily. Can you answer this question also before I move to sum of factors? Find the total factors that are square numbers. Abhi kya karna hoga? If I wish to find square numbers. Vijay is asking trailing zeros में भी यही concept use होता है ना? Yes, trailing zeros means that zeros at the end. That's the same thing which we look there also. Yes, that's correct. Lakshmi Narayan, अभी हमने यही बात की, multiple of 100 means the numbers which are having 2 or more zeros at the end. So they need to be subtracted from that case. Okay, now please answer this. In this question, I want to find the total factors that are squares. So for squares, what we need to do? We need to only consider the even powers, right? Even powers only. Yes, perfect, Ankush. So for even powers means I can consider 2 power 0, 2 power 2, 2 power 4 or 2 power 6. Only these 4 combinations or 4 possibilities for powers of 2, right? Similarly, for power of 3, if we see, so again 4 possibilities, that is 3 power 0, 2, 4 or 6. And for powers of 5, you can see 0, 2 or 4 only. So any combination of these numbers will give you a factor which is perfect square, right? Yes, that's correct answer. 48 will be the answer. Now quickly, when we are to calculate perfect cubes, what we need to focus on? We skipped question 8 intentionally. We did that already. That's why I left that. In case of cubes, what we need to look for? Now we need to look for the powers which are multiples of 3, right? So here, 2 power 0, 2 power 3 or 2 power 6. There are only 3 possible ways to be considered for powers of 3, powers of 2. And similarly, powers of 3 ke liye bhi we have these 3 cases, 3 power 0, 3 or 6. 3 possibilities. And for powers of 5, we have only 2. That is 5 power 0 or 5 power 3. So total combinations comes out to be 3 3s are 9 and 9 2s are 18. There are exactly 18 factors. Yes, that's correct. Powers should be divisible by 3. So basic point is that your concept must be clear, right? If your concept is clear, then whatever conditions may be there, you can always find the answer. Okay, let me proceed further now. Yes, we finally reached to this part. This part also needs to be discussed. And after that, I'm going to take your doubts if there are any. Okay, sum of factors. Why do we consider 2 power 0? Arey bhai, when the power is 0, tell me, is 0 divisible by 3? Yes. Is 0 divisible by 2? Yes. Right? नॉन प्राइम वाला समझा देना भास्कर बोल रहे हैं. ओके भास्कर, नॉन प्राइम और कंपोजिट का ही हमने उसमें डिफरेंस किया था. डोंट वरी, दैट वाज वेरी इजी थिंग. मयंक बोल रहे हैं क्वेश्चन 8 दोबारा समझा दीजिए. 8 क्या था? 8. अरे बाबा, प्रोडक्ट ऑफ ऑल द फैक्टर्स, नंबर रेज टू पावर नंबर ऑफ फैक्टर्स बाय 2. नंबर, यू नो, नंबर ऑफ फैक्टर्स यू कैन कैलकुलेट, डिवाइड बाय 2. दैट्स इट. दैट्स क्वेश्चन नंबर 8. ओके, सो डोंट वरी, वी आर नॉट स्किपिंग एनीथिंग. I'm just skipping those things which we have already discussed. Okay, अरे फिर से रिपीट, कौन सा क्वेश्चन 10? क्वेश्चन 10 क्या था? Cubes ये लिखा ना बेटा, as we had done for square numbers where we are considering even powers only, same way for cubes we need to consider the powers which are multiples of 3. Isn't it? So that's what we are doing. 2 power 0, 2 power 3 and 2 power 6. And some of you were confused about power 0, so don't be. 0 is multiple of every number, right? So 0 will always be considered. So 2 power 0, 2 power 3 or 2 power 6. So there are 3 possible ways to select any power of 2. Same way there are 3 possible ways to select a power of 3. And there are 2 possible ways to select a power of 5. So total that makes it 3 times 3 times 2. That is 18 factors of this number which are perfect cubes. Okay? Same way there can be any other question so that you can easily find out. Okay, without wasting time, I think we should discuss this part, and after that I'm going to take your doubts. If there are still any doubts, so hold on, don't worry. So find sum of all factors. See, total number of factors we have found out, and whatever different constraints are there, with that also we can find the total number of factors. So when we have to find sum of all the factors, so how to find? Again, there are some shortcut formulas also, but as I said earlier, not required. So what to do? Have your doubts, don't worry, don't write your doubts right now. Let me discuss this part, after that we will take your doubts. So while considering sum of all the factors, what we need to do, the basic thing is that whatever possible powers were there, whatever possible powers of 2 were there to be considered, we need to write their sum. For example, in this case, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. And all these powers of 2, right? This is of not much use, but still, we should know how to calculate this. Okay, before considering this directly large number, let's work on the smaller number first. if we need to calculate the sum of all factors of the number 12 only, let's say 12 means 2 square into 3, right? Right? So if I write all the possible powers of 2 and 3 to be considered, so it can be 2 power 0, 2 power 1, 2 power 2, right? And 3 power 0 or 3 power 1. ठीक है ना? तो total there are going to be 3 into 2, total 6 combination, that is 6 factors, right? Now what are those 6 factors? That is 2 power 0 into 3 power 0, 2 power 0 into 3 power 1, 2 power 1 into 3 power 0, 2 power 1 into 3 power 1, same way 2 power 2 into 3 power 0, 2 power 2 into 3 power 1. Now if I need to calculate the sum, तो अब इसको हम कैसे निकाल सकते हैं? तो उसके लिए what we need to do, add all these values, 2 power 0 plus 2 power 1 plus 2 power 2, ठीक है? And multiply it with sum of these values, that is 3 power 0 plus 3 power 1. Now think very easily. If I multiply, if I open these brackets, what we are going to get? Will any two terms of this bracket are going to be multiplied together? No. Right? They are not going to be multiplied together. What is going to happen when we will open this product and open these brackets? This one term will be multiplied with both of these. So 2 power 0 into 3 power 0, that is one of the factors. 2 power 0 into 3 power 1, that is one of another factor, right? Then 2 power 1 will be multiplied with both of them. So 2 power 1 into 3 power 0 is another factor. 2 power 1 into 3 power 1 is also a factor. Same way, 2 power 2 into 3 power 0 and 2 power 2 into 3 power 1. So basically, when we are writing these all possible values, all possible powers of prime numbers in this format, we are going to get simply sum of all the factors, right? So see, in this case, it was this one only. So 4 plus 2, 6 and 1, 7 multiplied with 3 plus 1, 4. So 28 was the answer for the number of factors, sum of all factors for this 12. Now exactly same way, if I apply the same concept for this large number, I need to add all the powers of 2 from 0 to 7. For 3 powers of 3, it will be from 3 power 0 up to 3 power 6. And for power of 5, it will be 5 power 0, 5 power 1 up to 5 power 5. Now, if you see it mathematically, that becomes product of 3 geometric progressions, GPs. So there are some formula for summation of GP that you can apply. Otherwise, you can directly add the numbers also, as I have just done here, right? So that is the basic thing. So we have understood the basic concept by using a small number, and I would certainly recommend that you think about this small example only. Just try to understand this small example, then you can easily extend the same logic in any number, Okay? So I think we should stop here. And if there are any confusion, any doubts, I will highly recommend that many things were discussed in today's session. So certainly you should repeat the things which were not very clear while discussing here. So you can repeat those things. And many of the things have already been discussed in conceptual videos also. Of course, not everything, but many of the things. So you can watch, you can take help from there also. If there's any confusion, if there are any comments for today's session, any feedback, if you have found anything good, you can write in the comments. That is the only motivation, only food. नॉन प्राइम, हाँ भास्कर, नॉन प्राइम का मतलब है जो नंबर्स प्राइम नहीं है, राइट? सो टोटल फैक्टर्स you can easily find out for any number, and you just need to subtract the prime factors, right? So that's what we did in that question. So total factors minus prime factors, that will give you non-prime factors, right? Shortcut for last day's homework. Shortcut मुझे नहीं आता, and I don't prefer. What was the question? I forgot that. Please write the question I would like to discuss. Thank you. It was great. Thank you. It was great. Your participation was great. I should certainly thank all of you. हाँ, इसी का कंपोजिट में हमने डिफरेंस किया था बेटा, प्राइम के अलावा नॉन प्राइम के अंदर 1 भी आ गया था. कंपोजिट के लिए हमें 1 को भी माइनस करना होगा. दैट वाज द ओनली डिफरेंस. थैंक यू सो मच एवरीवन. Okay, so I shall take your leave now. I think all of you are having some practice session or something, but application session also today. So solve questions there, and now we are going to meet on Monday with continuation on this numbers topic. All right, thank you.